Just 2 minute, ma'am. I will be starting this presentation. Let me go for beginning slide. So, yeah, good morning, ma'am. Today I'm gonna to present topic optimization of loss function and the benefit of the line using the gradient uh, descent. So, this presentation explores how the regression helps finding the relationship in between the data and how the gradient descent optimize models to make the better predictions. So, here my name is Pratik Patil and my PRN is 145 and my roll number is EDA 41 and I am from Division B. Yeah, now we will move on for index slide number 2, which consists of index. What we are going to see in our PPT presentation. First one, we will be introducing to the regression, finding relation in the data. Second, we will see the linear regression equation. Then identifying the best fit line. Then we will see the error and residential. After that, we will see the optimized goals, then introducing gradient descent, that second part, and then we will move on for gradient descent. Afterward, impact of the learning rate, and finally, we will sum up with summary and the key point we are taking that. So moving to the main our next slide, that is the introduction of regression. What is regression basically? Regression is one of the most fundamental concept in data analytics and machine learning. So it especially helps us understanding the relationship between two or more variables. Uh, like uh, uh, it just for example how the house price depend upon house size, right? The independent variable like house size is plotted on x-axis for example, and then it's depend upon variables such as the price, that's the y-axis. So what we see here, there is a dependency upon the variable. So the goal of the regression is to find the line or the curve that represent the trend of the data. So what we can be the best fit line, or it's widely used in many fields like economic, engineering, and science for that. Right. So now we will move on for slide number 4. Slide number 4 consists of the linear regression equation. This slide is also pretty much important, where we see the main equation y is equals to mx plus c, right? So this equation, as we have heard in our 12th class, where m is basically the slope, showing how much y is changing with x, and c is just the y intercept, and the value is basically helping us the model or predicting the outcome. So it will helps to predict our outcomes, right? So it's just a simple slide. Now I will move on for the next slide. It's basically consist of our title, identifying the best fit line. So it's pretty much important, where we see the best fit is one of the best representation of relation between input output input output variable. So we usually find it like uh, list square method, which minimize the sum of square difference between actual data point on the line. It's widely used for prediction, right? So by calculating them, we calculate the slope and intercept that may minimize the total error. So, moving toward the next slide, error and residual. How even the best fit line is doesn't pass through every point. Yeah, there is always some difference. The difference between the actual value and the predictive value is called as residual. as we see here in third point, right? So here one of the example we have taken, if actual house is price 5 rupees, 5 rupees lakh, and then model predicted is 4.5 lakh, then the residential is 0.2 lakh as per calculation, as we can see here. So our goal is regression is to minimize this residential as much as possible. We will go to the minimum of residual point. So our to optimize this goal, we use the minimizing loss. Means just like the adjusting the model parameters, difference between actual value and predicting value, which will be smaller as possible. So how we are going to see that, to measure the overall predictive errors using the loss function, commonly the mean square error, that is MSE, right? So this where optimizing algorithm for gradient descent comes in the place. Then the gradient descent, what is meant by the gradient descent? Uh, that's optimizing algorithm which is used to find the best fit line or model by minimizing the loss function. Yeah, it's also work as a iterative way. Firstly, we start with random value from the slope, and then intercept. Then we calculate the loss and compute how the parameters are gonna to affect that loss, and then update them into the direction that reduce the error. So we repeat this process until the loss stop changing significantly, meaning we found optimal parameter, right? So the next step, what are the step for these mechanisms? So first step, we will be initializing parameters. It's very simple. Then second, we will see for making the prediction. Then we will go for calculation the loss of error. Then we will go for computing gradient. That formula is L is equals to 1 upon L summation of y minus. That's completely pretty much easy. Then updating the parameter, then repeat it until the convergence, right? Then the impact of the learning rate, that's alpha. There are three types of we have ever seen, that is denoted by alpha. Control how the big parameters updates are in each step, and alpha is too small. Converge before become very slow, so it covers large of might of overshot in the minimum fail to converge. Right. So we are here at the last slide, that summary and the key takeaways. So regression predicting models relationship, which basically helps for finding mathematical relationship between input x and y. It's identify the best fit line for predicting the outcomes accurately. Secondly, we see loss function, which is very important for measuring error. So loss function is used used for predicting for the actual result, or loss better for the better performance. After that, we seen the gradient descent, which is optimizing tool, which is very important. Iteratively updated the parameter, which reduce loss and make it the best fit line, which is very important for machine learning training. So the main applications are where we use that in the stock market, price prediction, or trend forecasting like sales or weather or anything regard the geography. Also, thank you for having me having this presentation. Thank you so much.